Ladies and gentlemen, please welcome to the stage our panel moderator, Marcy Offner.
Good morning, everyone. As mentioned, I am Marcy Offner, Director of Marketing Communications at Composites One, and a founding member of the CAMX Steering Committee. It is so exciting to be here at CAMX this year and to have the privilege of moderating our panel today at this new and exciting event, Good Day CAMX. And for our inaugural event, we have done it right by inviting some of the industry's best and brightest innovators to share their story about bringing new thermoplastic technology to the composites market. And just to make us all feel good, at the heart of our discussion today is collaboration. We all know that with collaboration comes great things. And with advanced materials like thermoplastics changing the manufacturing landscape, it is critical to create partnerships that showcase the benefits of high-performance materials in developing market segments, bringing advantages to the manufacturer while simultaneously growing our overall industry right here at home. We are about to embark on a lively discussion as we present an exciting collaboration led by Rebuild Manufacturing along with their partners, Elroy Air and Victrex, as we discuss how they are producing next-gen aerospace certified structures and leading the adoption of thermoplastic materials. With a collaboration like this, there is no doubt that the use of these exciting materials will grow faster than ever before, which is something the entire composites industry can learn from and be excited about. So let's meet our panel. Miles Arnone is the CEO of Rebuild Manufacturing, a family of industrial businesses combining cutting-edge enabling technologies, operational superiority, and strategic M&A to build America's next-generation industrial company. Its goal is to revitalize the U.S. manufacturing base over the coming decades, creating substantial opportunities for its employees and the communities where the company operates. Miles' experience has concentrated on the evaluation, acquisition, management, turnaround of technology, and industrial-oriented businesses with sales from $10 million to $250 million. From 2002 to 2016, Miles worked at American Capital, a publicly traded debt and equity provider where he oversaw over 36 technology and manufacturing businesses, inclusive of venture opportunities and turnarounds. He left American Capital to co-found Cannon Capital, a boutique investment company investing in 5 firms through 2020. Miles' experience in the U.S. industrial market over this period and the supply chain disruption that arose due to COVID gave rise to the idea for Rebuild Manufacturing, which he founded with Jeff Wilkie in 2020. Let's welcome Miles Arnone. Here he comes.
Good morning, Marcy.
Hi, Miles. Welcome. Thank you. Joining Miles today on our panel are 2 of his industry partners. Jay Wakenshaw is the Chief Operating Officer at an emerging Northern California aerospace and defense startup, Elroy Air. Elroy Air designs and manufactures large cargo-carrying unmanned eVTOL aircraft to serve the needs of both the defense and commercial logistics markets. Elroy Air was founded in 2016, has close to 70 full-time employees, and is in the midst of rapidly scaling its business in many areas. Jay lives in the California Bay Area, was born and raised in the UK, has lived and worked in 4 different countries, and has spent most of his career here in the US. He holds a mechanical engineering degree and an MBA from the Wharton Business School. Jay's 25-year career manufacturing spans medical device, automotive, but predominantly has been in the aerospace industry. His experience covers aerospace engines, structure, tooling and automation, advanced carbon composites, and more recently, eVTOL vehicle production. He has held successive leadership positions in publicly traded companies and held executive-level roles for more than 10 years in private equity or venture-backed aerospace businesses. He is a domain expert in fixing, scaling, and improving production operations and business systems, and is currently busy architecting and leading Elroy Air production operations and supply chain scale-up and strategy execution. Let's welcome Jay. Good morning. Thank you. Jonathan Sirks is the head of sales, Aero SBU at Victrex. He is a highly experienced business management professional with a record of developing strategic direction and creative processes in various incumbencies. He is a high-level operations management and strategy development specialist that consistently improves organizational effectiveness through cost savings, accelerated performance, and strategic flexibility. He is a builder of high-performance teams and a natural leader, mentor, and motivator who thrives in fast-paced and complex environments requiring a high-level strategist and a big-picture thinker with a strong background in finance, operations, strategy, customer support, and revenue cycle management. Please welcome Jonathan. Good morning, Jonathan. Thank you. So we'll get started. Gentlemen, I am very excited to have you all here to discuss your project and your collaboration and maybe some of the lessons that you've learned over the last couple of years. Let's begin with that partnership between Rebuild, Elroy Air, and Victrex. Miles, I would like you to kind of tell that story and highlight what brought the three of you together and what was the common goal.
Great, sure. Well, I think to begin, both Victrex and Rebuild have pretty considerable capabilities in the thermoplastics composites area, right? Various complementary capabilities, whether that's compression molding or sheet molding, over molding, et cetera. And we both have an interest in participating in the aerospace market. What we wanted to avoid, however, was the traditional approach where a prime drives a design element into a product in a production process that leads to what could be a decades-long kind of process of adoption of this technology. We see real ability for thermoplastic composites to drive substantial cost improvements into the market and performance as well. So we decided to collaborate and try and identify an area that we could, organically from the bottom up, develop a product that would provide a substantial benefit to the market and demonstrate the value of these capabilities. So we ultimately chose rotor blades. We felt that was an area, particularly as it related to servicing eVTOL, drone, UAM markets, that was not well served by the market, and it needed a substantially more cost-effective solution given the value of those products and the number of them that need to be made. So we started to collaborate around that and develop technical solutions, but we realized very quickly that it was also important to have a customer lead. So a customer that would be able to engage with us in a very collaborative way and not insist that that technology be captured within their own base, but could be used more broadly, because we felt that was better for all parties involved. And so, one of the nice things about the composites industry generally is there's a lot of interconnection between people, a lot of inherent kind of, relationships that have existed over many years. People come into the industry and they love it and they stay, whether they move from one company to another. So we knew Jay there, and so ultimately approached him about being a part of this project, and he saw the benefit not just for Elroy, but I think for the industry as a whole, and agreed to come into our collaboration.
Perfect. That sounds like a fantastic collaboration, and I know we all can't wait to learn more. So let's really dive in now. I'd like to start with thermoplastic technology. It's really a hot topic in the composites industry right now, and it would seem that, as you were saying, that's the technology that brought this collaboration together. So Miles, let's start with you and Rebuild a little bit. You like to say that it's your goal to bring manufacturing back to the U.S. I can tell you that all of the composites industry in North America would love to see that happen. But what about thermoplastic technology makes it ideal for helping to accomplish that goal?
I think the primary aspect of it is that it's very affined to automation. So the nature of the thermoplastic composite materials is that they're more easily automated from a layup perspective, a forming perspective, and so on. And so you can operate in an environment with a high labor cost, which we have, and frankly, we want that. We want to have a country where people are paid well for their work and so on, and not be chasing the cheapest labor possible. And so thermoplastics are a good fit for that. Whereas, with a lot of thermoset applications, they're very labor intensive, and there's often this process of chasing the cheapest labor to facilitate production.
Right. So with the Elroy Air and the Victrex partnership, whose idea was it to champion the use of these products? And how have you worked together to do so?
Yeah, it's a tough question. In hindsight, it's hard to say where that spark first came from. I mean, I think the fact is that, both Victrex and Rebuild have extensive, capabilities in that area, and so it was natural for us to want to do that. But we also know that we don't have all the knowledge that exists no company does. And so really important to build a group of companies that can collaborate. In the US, typically, you don't see that as much as I think we need to. And we have a lot of small to mid-sized industrial businesses. And frankly, if we're going to compete on the world stage, we have to collaborate much more closely to create that effective scale that you might see, for example, in a large-scale Chinese or Korean business, for example.
Yes, I think that's really exciting and a very important message to the industry. Jay, let's move to you. At Elroy Air, the development of your rotor blade for the vertical takeoff aerial and cargo aircraft seemed like a natural for thermoplastics. Can you elaborate that on a little bit?
Yeah, sure. The thing about our air vehicle, and many of these vehicles is there's a lot of these blades on the aircraft, right? So for example, the Elroy Air Chaparral, pre-lift vehicle, and it's got 8 vertical lift propellers. So that by definition is a lot of blades we're going to need. Not immediately, but as we get into the rate production, we're going to need a lot of blades. They're also a wearing part of the aircraft, so they're going to need to be replaced over time as they go out in the field into those kind of environments. So the rate was first and foremost the key driver, right, as we talked about the project. And then secondly, just the material characteristics of thermoplastics. It's tough as old boots. It's got some inherent advantages, maybe for stiffness, certainly weight. And those properties really matter on an electric VTOL aircraft for sort of control reasons, control authority of the vehicle. So it's a little different to, like I say, a forward prop. It just is a very highly technical part of the aircraft. And lastly, it's an area of the aircraft where we can really take that level of risk to try and push the technology, push the innovation. You can replace that with other lift props if you need to, right? It's not baked into the fuselage, for example. So it's something we can take that little bit more risk, work a path that could get us down the path on certainly certification reasons, but also just to try and push the envelope a bit here. So that's really why we chose the lift prop and why it's a good fit for the vehicle.
Okay. Well, Jay, obviously for years, manufacturers in general have been looking to the aerospace industry for inside innovation and how they could apply those types of things in their own businesses. What are some of the lessons learned from this particular project that could apply to the greater composites and advanced materials industry?
Yeah, I think one of the things, I think Miles has touched on this, but I think part of it is it's sometimes, especially in such a controlled, governed industry, it takes a bit of leap of faith sometimes to push the innovation boundary, right? People tend to tack conservative and take that sort of safe option. When it comes to this sort of collaboration with like-minded companies, want to push the envelope, all bringing to the table some investment, some skin in the game, some mutual wanting to get it done. It takes a little bit of risk out of it, right? We're all co-investing, right? It brings the threshold to say, yeah, let's go get this done. It brings it down, so that collaboration effect is really great because it's not just one company carrying all the risk, all the capital. We're bringing that technology and that sort of expertise, and by the way, it's not just us guys here. We've got great teams doing this, right? Bringing all that together and really going to make something happen. So that's really what I think is a format, I guess, that could be applied not just to the aerospace industry, but other adjacent industries, to just allow people to take a bit more measured risk.
Yep.
Yeah.
I know I find myself thinking about other areas as I'm listening to you speak, and hopefully everyone in the audience is doing the same today and thinking about how you can apply some of this back at home. Jonathan, obviously the adoption of thermoplastic polymers in applications like rotor blades and others will lead to disruption. And disruption can be good, but it might even lead to the disruption of more traditional composite materials. Your role in this partnership is unique because your product could displace another kind of composite material or another traditional material. How did you support the collaboration of this adoption of thermoplastic technology, and what would be your message to our audience about disruption and why it might be important?
Yeah, I think generally what we try to bring to the conversation with our customers and the industry in general is just this role of trusted advisor, and we attempt and try to stay very intellectually honest about the overlap between, say, the application space, the available manufacturing technologies, and the materials. So we try to bring to the conversation the idea of narrowing in on right material, right processing method for the right application, and bringing that focus in and using our experience and our interactions with other industries and other customers to try to say, okay, we see this part, we see this application, we understand the demands, it ticks all of those boxes, and Rebuild has certain capabilities that can leverage the material properties, and Elroy knows the application demands or the stresses and the strains and whatever else is required in that operating environment. So to kind of bring that 30,000 foot view and provide expertise, I think is a key responsibility, because nobody wins if we cram a low melt PATE carbon fiber solution into an application that would just be better served by nylon or a phenolic resin or traditional subtractive metal, right? So there's enough opportunities out there, whether it's in commercial aerospace or AAM, where we can now leverage everything that's available to us to provide the right solution.
Okay. So along those lines, we're talking about an aerospace project today, but what could be some other areas of industry where this technology could be considered, and how are companies like yours paving the way for helping manufacturers consider options like this?
Yeah, I think the generic answer for thermoplastic composites is really to chase rate, right? Where you have applications that require high levels of repeatability, high production numbers, you're going to be better served using thermoplastic solutions. But also looking at the inherent properties. So if I talk generically about thermoplastics again, I would say Jay touched on it earlier when he mentioned the inherent toughness of the material. So finding those right applications with the rate requirements are going to, I think, steer us all towards thermoplastics. And then you layer on top automation and repeatability, and I think you end up with a really good solution. So I wouldn't so much focus on the market, I would focus on that application space.
Okay, perfect. So let's move a little bit and talk about some of the benefits of the thermoplastic technology. Miles, thermoplastic technology can reduce the dependence on expensive equipment in the shop. Can you maybe explain that a little bit for our audience today?
Yeah, and that's only half true, I would say. I mean, on the one hand, you don't have freezers at the front end of the process, you don't have autoclaves at the back end of the process, but you can deploy quite a bit of automation, and it can be expensive in the middle there, where you're actually forming these products because you're trying to achieve a high rate. So it's probably more appropriate to say that the capital per unit is reasonable. I mean, there still can be a pretty high fixed cost there. But the whole benefit, and really where that pays off, is that you don't have these batch processes as you might have with thermosets, right? So you can have much more flow. So you can have a lower tack time and achieve rate. And so you can deploy automation, even though it might still be reasonably expensive, much more effectively than you could in a thermoset composite environment, for example.
Perfect, thanks for that clarification. So does this also impact the design of tools and the ability to rapidly produce more parts? Yes, for you, Miles. Yeah, sorry.
Yes, certainly. I mean, the tooling design is quite different because, again, you're looking at volume, right? So again, if you're doing, say, stamp forming, the number of cycles that tool has to survive, the loads it has to undertake, the thermal cycling are all different than when you're building up a thermoset composite, laying it up on a tool that then is going to sit in an autoclave for X amount of hours. So there are certainly specific design constraints there that don't exist for other materials.
Okay, great, thank you. Jay, so how will thermoplastic rotor blades change the future of aviation, in particular the vertical takeoff, aerial, and cargo landing platforms?
Sure, I could expand on that one. It's thermoplastic in general is really going to be a key enabler to the change that we're seeing in aviation. I think it's an industry shift that's happening, right? The electrification of airspace, right? And particularly with the technology, the materials technology, the software, all of these technologies coming together to advance the industry. It's a very exciting time right now, right? The electrification is going to continue and carry on, and that helps drive kind of more carbon efficient, cleaner aircraft. For our vehicle, we actually have a series hybrid powertrain. And obviously, we want to make that as carbon efficient as we possibly can. But when you get to that level of electric propulsion, weight becomes yet more of a premium in aerospace. Rate is always a premium in aerospace, but like every last gram, every last ounce of weight on that air vehicle you want to shed. And thermoplastics is one of the key enablers to go and get that done, right? It can take weight out and provide that same level of, as Jonathan mentioned, that kind of properties you need to give that ruggedness and that just durability on the air vehicle. So I think clearly the electrification of the industry, scale is another big deal. I mean, we've touched on it a couple of times here, but if we do this right and we open up the airspace a little more than we have done in the past, and the AAM industry really blossoms and flourishes, and these really come to bear in a very meaningful way, we're going to see rates that we've not really seen in the industry at this level of rotorcraft, right? So that requires a different level of thinking, a different level of capital investment, different approaches. So I think it's yet another one of those, for the industry at large, it's another enabler of the industry to go and do that. And certainly for my position, as I look down the track, this is years down, but as we work through those gears and we crank up the scale and we start to put our product out in the market and get it into mission settings, hopefully we can go and make that happen. And this is one of those key levers. And I think, at the very start it was mentioned, not only are we taking, fossil fuel usage down and carbon efficiency down, but that sort of full life cycle aspect of the air vehicle is another consideration. It seems like a long way off, but you see a lot of traditional aerospace and composite aircraft structures just going straight into landfill or out in a desert somewhere. Thermoplastics is just another one of those, great materials, because you can take it at the end of its life cycle, useful life cycle, right? Particularly blades, they get chopped up out and go and chop them up and turn into a park bench or some sort of logistics pallet or some other useful item to repurpose it and use it again. So it has those sort of like full life cycle advantages. So I think there's a lot of impacts you'll see in the aerospace industry. I'm seeing it clearly from like overseeing the sort of overall air vehicle and its full product life cycle. But we'll see this more and more as time goes on. It's going to be more ubiquitous.
Yes, we're going to touch a little bit on the full life cycle and sustainability in a moment. And you've kind of touched on my next question, which was about how manufacturers can benefit from the higher rate of manufacturing. Is there anything further you'd like to add about that?
Yeah, I think it's you're seeing it across industry. Like the automotive industry is already on this curve of electrification, right? You saw it early with the sort of hybrid vehicles, then you go to the full electric vehicles. Now, Chaparral is one of those early hybrid vehicles in aerospace, right? So you're seeing this transition. It'll take longer, but as you apply that sort of kind of electrification of the industry at large across the board, aerospace, automotive, there'll be other transportation modes. Those sort of, for our society to get to that point and use electrification, things like weight and things like using advanced technologies and materials is just going to be necessary. So I think if you're in those adjacent industries thinking about this and going, okay, how do I get through these kind of like big shifts in the ecosystem, you're going to have to look to these kind of things to push the envelope and make it happen. So I think if I was in adjacent industries, I'd be thinking, okay, what are the big shifts and what are the big vectors here that we're aiming towards? And you're going to find that weight and carbon efficiency and those kind of technologies are going to start to become more and more needed.
Mm-hmm.
If I could add, the other thing I would just note is, it's also a lot less expensive. We think we can make these rotor blades out of thermoplastic composites for maybe half what a conventional product costs. So you have these other benefits, but we're also right out of the chute being able to provide something that's literally less expensive by 50%.
Right.
And that is very important these days, right? Where we can save money in our manufacturing process and bring it to market. So let's move to sustainability. Jonathan, obviously the entire industry, really the entire manufacturing industry right now is focused on sustainability. Your company, Victrex, has made an impact with thermoplastic technology in this area. Can you provide an example or a learning from this particular project or any project that might relate to sustainability?
Sure, yeah. I think when you approach a project like this and with the sort of renewed emphasis on sustainability, it's incumbent upon you to look at the full life cycle and make decisions around the design for manufacture and design for the application with sustainability in mind. So being thoughtful about, do we use adhesives that would make recycling difficult, or do we mix material that in that solution that would make it more difficult at end of life to recycle? So, you have to keep all of these things in mind to manage that sustainability picture. And, to the point like we're in our project, like we are investigating two parallel paths, and, while they both may meet the application demands, one may look better from a sustainability perspective, and then we'll have a decision to make.
Yeah.
Right?
So in general, though, with thermoplastics, how do you kind of see them fitting in overall in that sustainability puzzle that we're all trying to solve in the composites industry right now?
Yeah, so I mean, if we look and you talk about CO2 emissions over the last 20 years, they've doubled, and aerospace is not immune to that doubling. So 20 years ago we were providing 2.5% of the CO2 emissions, and that's still true today. What is happening though is other industries are able to move a lot quicker. We have a 30-year life cycle for commercial aerospace, right? Automotive may have a 3 to 5 year. So now that everybody's talking about sustainability and really serious about it, you'll see the other industries start to cut their share. And if we're not aggressive with our approach, our 2.5 is going to become 5, right? Or maybe worse. So where I think thermoplastic plays a role is in not only in that full life cycle analysis and the recyclability, but also in the weight save, eliminating fasteners, getting rid of adhesives, being inherently tougher. So now maybe, instead of having a part that has a 5-year life, maybe it has 7, whatever you can prove through that fatigue analysis and get the certification authorities comfortable with, right? So I think we have a major role to play in curbing the CO2 emissions for the aerospace industry. And then specifically on this project, being involved with Elroy and AAM and electrification in general, if we can turn a bunch of these shorter duration trips from burning fossil fuels into zero emission electric transportation, that's also going to play a big role.
Yeah,
now, what percentage of the population is that? Well,
I don't know.
we hope it's big, but it may not be the biggest contributor. But I just think with thermoplastics and driving the adoption into commercial aerospace that we'll start to see those effects.
I think that's really exciting, and I think, as an industry, we can all, it's all coming at us really fast, so things are changing, and it's great to know that we're exploring this particular area. So let's round out our discussion today, going back to where we started, about collaboration. I think that's just really an important lesson for our audience to take home today. And this is really a question for any of you, or all of you, that are here today, but how did you collectively work together to forge success for this project on the rotor blade?
I'm happy to take a start on this one. I think if I think back to the first discussions we had on this, sometime early last year, I think, and obviously we're partway through this project. We haven't got to the end of it yet, but I feel like the collaboration made a lot of sense. I've said we're kind of like-minded companies. We're all bringing that sort of technology together. And I think from my vantage point, I got the privilege of being able to then say, okay, yeah, we can help give the clarity of the application, and these guys can help us go and think about how we get that done. And then very quickly, then we can go and get it put onto a thrust stand, and we can get it onto our test beds, then eventually, and pretty readily get it onto the air vehicle and go off and hopefully fly this and prove the point, right? So very quickly, and this is a rare day in aerospace, you can see these things materialize and then go out and actually fly it or go and see it work and like make it happen. So that was really, we could see that runway within a short order, and that was pretty exciting. So I felt like we can go and get that done. And Elroy is still a young company. We're scrappy, we're innovative, and we can go make those calls more readily than, say, a more established contractor, right? So That was kind of fun for me as I think about the collaboration. We can really see the fruits of it within a short period of time.
And I think we're really trying to change that paradigm. So your traditional aerospace paradigm is very top-down driven, and we're trying to use more of an industrially oriented approach. I think it's fitting for the materials well, which is kind of more industrial in its production methods, right, at scale, and try to cut the design and development cycle down dramatically so that 30-year cycle that Jonathan talked about earlier, we'd like to see that become a tenth of that over time, right? And if we want to keep evolving the industry and creating more efficiency, whether that's for environmental purposes or cost purposes, we cannot take the amount of time it takes now. We cannot have top-down driven decision-making about product and process from the primes forced upon the supply chain. We have to, as a supply chain, ideate on our own and develop process and put them forward. And working in this environment, particularly with a company like Elroy, but in the general class of kind of more innovative aviation, there's a lot more tolerance and willingness to experiment and try and rapidly iterate. So I think that's, to me, the essential element of this collaboration, why it's successful, because everyone's committed to that idea that we're going to fail forward fast, like we're going to make mistakes. That's all fine. You learn something, and we go on from there, as opposed to we're going to sit at our CAD stations for I don't know how long and optimize the thing, and only then move it into some prototype, and that takes years, and that just doesn't work. There's too much need for empirical data that you can't just design your way into.
Jonathan?
Yeah, and maybe this is also what Miles was getting at, and it sounds, I think, obvious when I say it, but we talk, right? Like, and having transparency and a regular cadence of communication, instead of, delivering a set of requirements and then going away and working on it and then coming back and hoping or expecting that you got your understanding correct and your solution is appropriate. We're interacting very regularly. So I think when we talked about putting this collaboration together, the resource requirement and the cadence for our communications was probably the thing we talked about most, and starting it at a point in time when we could all focus our resources on the project, because you're not going to go fast if each one of us has these other competing and can't carve out the time to work on it, right? So there was an upfront commitment to dedicate the resources, and we communicate regularly.
Yeah, and I think Jonathan mentioned earlier, it's not us, right? So, I mean, unlike, I think, more established businesses that might be in the space, it's not as hierarchical in our companies, and so there's a lot of peer-to-peer collaboration without going up the food chain, getting approval, going across, coming down. That all takes time, that's all waste, right? What generates progress is when the people that have to do the work, the engineers, the applications personnel, production people, can engage directly with each other, and we've kind of tried to foster that sort of collaboration. And I know, like our team at Rebuild, there's a lot of people involved that all have a part to play, and we expect them and trust them to go do their work, as does Victrex, as does Elroy.
Well, obviously the message is here that these end-to-end collaborations are really important and critical. I'm going to change up the question a little bit then here. So what would your advice be to other companies who are looking for this type of opportunity for end-to-end collaborations? Maybe they have an idea, but they don't have all the experts necessarily in their company or on their teams. What would your advice be to other manufacturers, other suppliers, other innovators out in our industry, how they can forge those types of relationships?
Yeah, maybe I'll take this one first. I think the point of doing this type of project is to validate all of our independent, internal to our business assumptions, right? So, Miles talked about failing fast, right? So we can do a bunch of work on how fantastic our polymers are, or how great this particular manufacturing technology is for an application, but you don't know until you work on it, because there's maybe it's you have a list of 5 things that you must be able to accomplish, and you could tick all those 5, but there's something else out there that's going to kill you, and you'd rather learn that sooner than later, and you can do that by working on a real part.
Yep.
I think one thing I'd say, just a slightly different point, but I think in this industry particularly, it is things we're trying to do is they're really challenging, right? We're pushing the envelope, and it's not one team or one small team isn't going to get there. It's really a team sport, and I think you mentioned it talking. It's really as you grow into the industry, understand the supply chain, you understand the players and who can do what, and putting those building blocks together is key, right? So it's advice really, as I've done in my career, is keep in touch with people, stay abreast of what's going on, right? Keep that network active, because when you need to bring those right skills together and make it happen, then we've got the right players and we can do that much quicker than you could if you just try and do it theoretically. You kind of, I know this, you save months that way. So that sort of collaboration networking effect is really helpful. Like we've got people from answer engineering in this project and other adjacent people that are coming to help and coming into the mix here. And that happens through building those networks and building those sort of relationships. And that's just so much more powerful than one team in one company, right? So that's we're hopefully proving that out and going to sort of model the way here.
Mm-hmm.
I mean, I guess I would add to that, I think transparency is very, very important. So, transparency and treating each other as if we're all on the same team, as opposed to trying to squirrel away information and only share some at an arm's length with, which is a typical sort of vendor-customer relationship, maybe in the auto industry, or a lot of other industries, aerospace sometimes too. So we try to, with all of our customers, be very explicit about, this is what it costs for us to do this, and this is how we should share the profit from doing that. And then we have a common understanding, and you get that out of the way. Like the amount of time we spent in this arrangement contracting, it was very small compared to the work, and that's not always true. Sometimes those things go on and on and on. But when you have a common understanding that you're going to be open and share information and be honest, it takes away a lot of bureaucracy that's really, again, waste.
I really, really appreciate this story of collaboration, and I really think that collaboration is the key to the future success and hope of our industry. So let's wrap it up with one more question, and Miles, I'll let you take this one. How will partnerships like this help us bring manufacturing back to North America and the U.S.?
That's a good question. So I think, look, it's very important to begin that we do this, that we bring manufacturing back from a national security perspective, from the ability to provide jobs that are a road to the middle class for people, et cetera. The U.S. market, I think, is kind of got two problems. One, there's a lot of small and mid-sized companies that have a very niche-oriented specialty, and that's kind of an island. And solutions today are systems-oriented, so no one has all the answers, and you're not likely to be able to get the capital or the people or the time to do it all on your own. So you must collaborate with others, right? And you see that in other cultures, they do it differently. We have to find an American model of doing that, right? And we have to do that rapidly. And the only way to do that, again, is to have a very trusting, open, collaborative environment, be willing to share information to get progress that we all can benefit from. So I think it's not so much how that's going to help us, it's that if we don't do that, I think we're doomed, basically. And so when you do collaborate like that, it allows you to have an impact that's much larger than any one of these companies could have on their own. And that allows you to be competitive on the global stage.
Okay, great. I mean, this is great stuff, guys. So how would you like to take a few questions from our audience today?
Yeah, great.
All right, so there is microphones strategically located. One there where lovely Carmen is standing, and I think one right over there too. So if you have a question, just walk towards the mic and we'd be happy to answer those today. Please tell us who you are.
Good morning, Monty from Boston. How you doing?
Nice.
I was wondering if you could elaborate a little more on the materials that you're using to get to these amazing strengths, and specifically what tolerances are you seeing for the thermal breakdowns?
Well, there you go.
You want to try that, Jonathan?
So
last one.
the backbone of the material system that we're looking at is Victrex's AE250, which is a low melting polyaryl ether ketone. It's at the top of the thermoplastic polymer pyramid. So it's a pretty high performing plastic, and we are going to leverage allowables data that have been generated and will be published through NIAR on the NCAP database. So there's 1,500 different coupons that have been tested at a variety of different conditions, and all of that data will be loaded or is being loaded into the modeling and the predictive analysis that we're doing, so that when we go to prototype these parts, we'll have a real good idea of how they're going to perform, and we're really just validating the analysis. So I think the key also to accelerating this type of project is to have data at hand to be able to make decisions around.
Okay,
Thank you very much.
thank you. So a young woman over there has a question.
Susan Ruth, Los Angeles chapter of SAMPE, now retired, but worked in the space industry most of my career. What I found interesting in your collaboration was today, at least, you made no mention of materials of origin, which I assume would be for Victrex, their supply chain, and no mention of the end user, okay, or the concept of operations at the other end. I'm not going to ask you because I suspect they were omitted for a particular reason, but are those things part of your collaboration?
I think I could probably take some of that. I think the Elroy Air Chaparral vehicle is it's an inaugural vehicle to the market, and we're going to go and serve several end markets. The different commands of the military, looking at this application as a platform for forward logistics, getting stuff where they need to be without committing, say, a helicopter crew. We're going to go into areas overseas in sort of humanitarian locations where, we're going to go and give supplies and food and medicines to remote communities. Those sort of operating environments are pretty tough. You have to have a pretty hardy vehicle to go off and survive and actually add value in those without breaking down all the time. So I think without getting too much the exact locations of where we're looking at, I think we've got to build, we can't just change the lift props for every single location and have different materials for different settings, right? We're trying to make a pretty generic, tough, robust article to withstand those kind of extreme applications. Even ship to shore or island applications, remote island. There's a lot of salt spray and it gets pretty rugged out there, so it's got to withstand all of that. And I think that's another reason why this kind of materials technology is just a good fit. So that talks to the sort of end application, and on the origins of it. I know that upstream, in the supply chain.
Yeah, really. I mean, I think we were hoping to make this talk really just about the collaboration and make it instructive to industry. So, while I love and am paid to promote Victrex polymer and their solutions, I think you could swap that out for somebody else's product or somebody else's solution and another end application and behave similarly and have an effective project.
Thank you. Thank you.
Thank you.
Let's see, we have a question over there.
Good morning, Stephen Mikos, Sikorsky Aircraft. So uniquely, I'm not a blades engineer, I'm a manufacturing engineer, but it's very interesting to hear the progress being made in this field. But what sizes of blade are we talking about here? I know you mentioned UAVs and drones. We're kind of uniquely involved in this space as well. So I'm just kind of curious, what are your sizes of blade?
How you doing? From a Sikorsky standpoint, from a traditional rotorcraft blade, it's nothing like that kind of scale. I can't give the exact. I should know the exact inches, but it's like maybe here, tip to tip. It's really not a helicopter blade per se, and I think that's by design, right? That's where the electric propulsion can get to, but it's also it's also so that, and it's actually our lift vehicle is it's a lift and cruise model. So we actually have, it's a fixed pitch blade set, right? Very simple. Another good thing about it's simple, right? It's simple fixed geometry with counterclockwise, clockwise blades, just exact matches. And they're highly redundant. So if the vehicle takes off, we hit a flock of birds or whatever, and one or two of the blades goes out, the vehicle can still fly with six blades. It actually can technically fly with 5 as long as which side of the vehicle it hits. But because of that nature and the sort of operating rationale for that phase of the flight, because once we get through transition, the vertical blades stow and they just park there for the rest of the journey, right? They're operating for 2 minutes and they stow and they need to just stay there and be lightweight and just not get in the way. So it's just a completely different animal to say a typical rotorcraft where that main blade is existential, right? That goes out, you're done. So hopefully that answers your question.
Yeah,
right?
no, just curious.
Yeah, in terms of the size and scope of it, yeah.
Awesome, thank you.
So it looks like we have very many more questions here, but I can take one more, and I know this young gentleman here has been waiting. And if you have any other questions, I'm sure that we can answer them after the panel. We'll stick around over there or something and be happy to answer your questions. But for the sake of getting everybody back to the show floor, we just want to stick with one more question.
Hi, Ben Lamb from Seattle, Washington. I work for one of the major primes. You can probably guess which one. So historically, my company has had a terrible time trying to partner with suppliers just because they're trying to get specific requirements on board, trying to figure out how we can get requirements flowed upstream rather than downstream. Were there any particular tools or techniques that helped you in that endeavor?
No, I think this is really about culture. So without naming names, we could talk about many examples where some large prime in the Northwest might dictate a certain process that we use and dictate that that process be available to our competitors as well, and dictate the price that we can make and every other thing you could imagine. And that makes it really hard for us to innovate for them. So what we would like to do, and we've tried to do in many cases with said unnamed prime, is suggest, hey, you want us to make this part this way, but by the way, if you let us use our own technology, we can cut the price by half. And they'd say, well, that would be great, but then we want to take that and send it to someone else also, right? And that's just not good business, right, for us. So I don't think it's about tools or anything like that. This is about culture, and it's about what the businesses are willing to share or not, and who should get the spoils. And unfortunately, I think in a lot of industries traditionally, you can think of automotive and others if we want to not speak to aerospace, there's been this kind of view that the prime should capture it all and that the suppliers should, love that. And that makes it really hard to innovate. And frankly, it's very short-sighted. It actually drives their costs up.
Right, and I would add to that final point. You mentioned this, Marcy. It's also strategy as well, because you don't need to protect everything you're doing, right? In fact, you've said this, but I truly believe it. If we get these blades onto these kind of vehicles across the industry at large, it's better for the industry and it'll accelerate the adoption faster, but it's also better for us here because the cost flow is going to go down, the learning will go up in different settings, and all of that will help improve the end product. So
For everybody.
Have it for everyone. So have that sort of strategic view. If Elroy Air really competed and thought, we're going to lose the competition with if we don't have the best blade, then we may put more of an IP fence around it, or a ring fence, or a moat. That wouldn't make this sort of thing go well. We compete on a different playing field, and you have to pick your spots about where you want to be, very, very refined. And this is not one of them, and it allows you to go faster.
Great, thank you.
Yeah.
Thank you. Well, thanks for such great questions. Thanks for your attention this morning, and thank you to our panel for sharing your story.